Okay, so we are going to start over here with trapezoid. Yesterday we went over parallelograms. Parallelograms has two kids, rhombus and rectangle. These shapes have the same characteristics as a parallelogram plus some additional characteristics. And then rhombus and rectangle have a baby and they call it a square. Square has all the characteristics of all the ancestors above it, rhombus, rectangle, parallelogram, and quadrilateral. And it makes this perfect little square. I would definitely use this as you're doing your ALEKS as well, because there's a couple assignments where you're just like talking about characteristics of shapes, and this would be really helpful. Over here, we're going to focus on trapezoid and kite today. So a trapezoid, I know you're probably familiar with what this shape looks like, but what makes it a trapezoid is it has one pair of parallel sides. So the bases of a trapezoid are parallel. So this is parallel to this, parallel here. It's different from a parallelogram because parallelogram has two sets of parallel sides, whereas trapezoid only has one. So here we can see the bases are both parallel. Here, bases are parallel. And then with those parallel lines, the angles, this would be a transversal, and then these two angles, this angle and this angle, would be consecutive interior angles, and those are supplementary. So star plus star equals 180 degrees. So these two angles supplementary. So if you need to find one of them, you just subtract from 180 and you can find the other angle. Okay, then from there, trapezoid has a baby, and we call it isosceles trapezoid. And so this trapezoid has all the characteristics of the ancestors, but in addition, it has its own characteristics. So isosceles trapezoid, it's like this. I'm going to draw it, try to draw it as perfectly as I can. Here's our trapezoid. We'll label the corners A, B, C, D. So an isosceles triangle, two sides are the same length. Isosceles trapezoid means the same thing. Two sides are the same length. And in an isosceles trapezoid, the legs are the same length. So the legs are congruent. And when that happens, the base angles are also congruent. So this angle, angle A, is congruent to angle D. And then angle B is congruent to angle C. So angle A equals angle D. Angle B equals angle C. Chris, can you write this down? So two base angles are the same measure. Base angles are congruent. And then one more thing about isosceles trapezoid has to do with the diagonals. So here's our isosceles trapezoid. Two legs are the same measure. And I'm going to draw the diagonals. The diagonals of an isosceles trapezoid are congruent. So diagonals are congruent. Okay, then one more thing we're going to learn about trapezoids. I don't know if it's considered a kid or how it would fit into the family tree, but the lesson today is on mid-segment of a trapezoid, mid-segment of a trapezoid, and so we'll learn what that is. And so down here, I'm going to draw a trapezoid. And so the mid-segment, it is a line that goes across the center. It's parallel to the bases, and it hits at the midpoint of each of these sides. So this line right here is the mid-segment of the trapezoid, and it hits at the midpoint. So like this is the same length as this over here, and then this is the same length as this. And so let's say this is length of A, and this is a length of C, and then this is a length of B. to find the midsegment, it's the average of these two lengths. So we can do A plus C, divide by 2, and we get the length of the midsegment, which is B, if you're thinking about it in letters. If we want to work with numbers, let's say this is 7, and this is, oh wait, sorry, this would be like 3. This would be the shorter side, and this would be like 7. To find the length of B, we just find the average of those two numbers. Some of you, or sometimes it might jump out at you, the average of 3 and 7 would be 5, so the length of the midsegment will be 5. But if it doesn't jump out at you, depending on the numbers, you can just add the two numbers, A plus C, divide by 2, and you will get the length of the midsegment, like that. Should you write this down too? Or write this down too? Okay. Aiden, please take out your AirPod, por favor. Other ear. Oh. Sneaky? Okay. Okay, kite. Over here, no parallel sides for a kite. It looks like this. You're probably kind of familiar with what that looks like. Things you need to know for a kite. The diagonals are perpendicular. So when I draw the diagonals like this, diagonals are perpendicular. Diagonals are perpendicular. This is a symbol, so that means that they intersect at a 90-degree angle. The other thing about a kite is like these two legs are the same length, so this is the same length as this, and then this leg is the same length as this. And then the other thing is that these two angles are congruent. So this set of opposite angles are congruent. So it had one pair of congruent opposite angles. And then something that comes up in the homework that I want to make you aware of is, so let's say that you have a kite, like this. I'm trying to draw the best one I can. So we have a kite, we have the diagonals here, they are perpendicular. And then in the homework, it might say, okay, this has a length of 4, and this has a length of 6. What is the length of this side here? Well, since you have a right triangle and these are perpendicular, you can use Pythagorean theorem to find x. So you just do a squared plus b squared equals c squared to find the missing side. So this would be like 4 squared plus 6 squared equals c squared. 16 plus 36 is 52. And then square root, and c comes out to about 7.21. So sometimes the answer choices will be as a decimal, sometimes I'll just leave it in this square root form. Either way, figure it out. Also, if you wanted to simplify this, just kind of quick review. Okay, so if you wanted to simplify square root of 52, break it up into factors. And then if you have 2 of the same factor, you take that out, and this would be 2 square root of 13, like that. Just FYI. That would be the simplified version. If I saw this as an answer choice, and I wasn't sure whether that matched square root of 52, what I would do is I would just do 52 square root in the calculator, get 7.21, and then I would calculate this to see if it equaled that decimal. 13 square root times 2, hey, that's the same answer. So you can use a calculator to kind of determine whether square root of 52 and this are the same thing, if needed. Okay, now we're going to transition over to the notes for 7.5, so take out your packet and then we'll go over to 7.5. So I'm going to pause this.